Hello friends, we will have a basic overview of a hydraulic joystick. Actually, a hydraulic joystick is nothing but a pressure reducing valve. What we have here is a graphic representation of an excavator's hydraulic system. It is just a basic thing. I have not added pilot pump, filters and valves. So here we have the hydraulic tank and the hydraulic here we have a gear pump, we have a pump which also comprises a gear pump. So the gear pump draws hydraulic oil from the hydraulic tank and it supplies a pressurized hydraulic oil to the joystick. Um, so it has a pressure of 40 bar. So when the machine starts and the safety valve is on, we have a hydraulic oil pressure of 40 bar at the joystick. So when the joystick operates, it supplies a pressure signal to the control valve. When the joystick operates, it gives a pressure signal to the control valve. The pressure signal given to the control valve varies according to the angle of the joystick. The more the angle we have, we have more pressure. It varies from 5 to 40 bar. The joystick is similar to a pedal valve or a treadle valve in the truck. The only difference is the pedal valve is pneumatically actuated and the joystick is hydraulically actuated. Once the control valve gets the required hydraulic signal, it moves the respective spool. So we have the control valve, we have some spools here. The movement of the spool controls the actuation of the actuator. It will control it may the spool may control hydraulics, the spool may control a hydraulic cylinder, or it may control a travel device, a travel motor, whatever it may be, or it may control a swing motor to slew the excavator. Yeah, the respective spools will have a respective function. So once the control valve gets the hydraulic signal, it moves the respective spool to activate the actuator. The movement of the spool is directly proportional to the pressure signal. So suppose and the pressure signal is directly proportional to the angle of the joystick. So by tilting the joystick, we are actually varying the pressure signal given to the control valve. Okay. So what we have here, we have a graph, and the graph shows the characteristics of the pressure signal from the pilot valve. Okay, in the x-axis we have the tilt angle of the joystick, and in the y-axis we have the pressure, we have the pilot pressure. Okay, the moment the joystick is actuated, it gives an initial pressure of 5 bar. Okay, and it goes all the way up to 40 bar. Okay, the maximum angle of the joystick varies according to the manufacturer's specifications. You have to see the joystick data sheet for the respective specifications. Okay, let us come back here. Okay, suppose if the actuators like boom or motors show no movement, or it moves slowly, the first thing what we have to check is the pilot pressure of the valve. And okay, okay, the common misbelief is that the moment we activate the joystick, the moment we move the joystick, it gives 40 bar pressure signal to the control valve. No, it doesn't happen that way. It's like an analog valve. It gradually increases. So if the moment we give the joystick, if it gives 40 bar signal, then it will be a catastrophe. So it doesn't happen that way. Okay friends. So what we have seen in this video is how the joystick circuit works in an excavator. So I will summarize this. The hydraulic oil is sucked from the hydraulic tank by a gear pump, and the gear pump supplies the pressurized hydraulic oil to the joystick, and from the joystick it is metered to the control valve, and the movement of the joystick and the movement of the spool in the control valve are proportional. So the movement of the spool actuates the actuator. So this is the brief overview of what we had in this video. So in another video we will see how a pilot control valve of a joystick works. Okay, okay, bye.